Hello, we are Morgan Stoner, Daniel Stillman, and Andrew Larson, and our Capstone project is a Bop-It game. So our Capstone project is more formally, it's a device which functions similar to the popular Bop-It toy, where a set of instructions are pulled from at random at an escalating pace, and the player is expected to complete them before the time runs out. Using four hardware units, a button, a tilt switch, a piezo element, and a microphone to act as input devices, the game prints the instructions to the terminal, which the player is then expected to complete to keep playing. The score increments with every successful round, which is stored in an external file and kept as a score. This is saved between games and allows the player to know if they are improving over time. The instruction which led the player to fail is also stored, with an external file keeping track of the instructions which lead to failure the most. The failed instructions and scores over time are visualized by a bar graph and line graph, respectively indicating the relative scale between the instructions which people struggle with the most.
Initially, when you click play, just like a normal Bop-It, it waits for you to click the Bop-It. So I click the Bop-It to start, then I wait for the first input. Asked me to tap it, so I tap the piezo element. Flip it, flip the tilt switch. Shout it, Bop it! Then I Bop it. But if I get the input wrong, so here it says tap it, what I flip it. And then it gives me the game over. So in here it shows me that I failed. It tells me that my score was 4, and it gives me a graph of how players have failed in the past, and of my score over time. The code has 4 functions that each handle checking the conditions to make sure that the user has done the correct action. The first one up here clicks to make sure that the button was pushed. This next one checks to make sure the tilt switch was flipped. This next one just checks to make sure that the piezo element was tapped. And this last one checks to make sure that you shouted into the microphone. Once you actually get down to the meat of the code runs through a while loop, choosing one of the 4 options each time. If the wrong action is chosen or isn't done fast enough, the player loses and the game ends. Once you get further into the game, it gets faster so that it's harder. Once you lose, it displays the graphs of how you lost in the past and of your scores over time.
Ultimately, the high score graph serves more of a purpose to the player than us as programmers. While details like an average score over multiple play sessions can be extrapolated from set data, there's little sense in terms of conclusions that can be drawn from a score list. The instructions which lead to failure most, however, do speak to the aspects of the game's design, such as the relative timer for each instruction needs to be variable in some instances, and serves to illustrate some underlying conclusions, which will at least serve to make the game more fun to play long term by tuning the balance somehow. When designing a project around something as arbitrary as having fun, it quickly became evident that extrapolating any data in a meaningful way is a challenge. However, considering that Bop-It is a game, then using data to ascertain how to make the gameplay much fairer and still engaging is the best use for data one can get into designing a toy such as this. Bop-It is a simple concept, but it lends itself well to a wide appeal. Using data like this is a small but meaningful way that appeal can grow in the future.